All right. Another important consequence of continuity is that if we have a function that takes on two different values. All right, so let me just draw a function here. All right, and let's say that we know at a the function takes on maybe another. I'll just say it 1. I don't know. Say it's 5. All right, and then we know that at maybe maybe out here at 1, 2, 3, 4, 5. So is this at 6? 1, 2, 3, 4, 5, 6, 6. All right, let's say at 6 we know that it's a -5. All right, so if the value of the function takes on those two values, then it has to take on every value in between. All right, otherwise we wouldn't be able to draw the graph of the function between those 2 points without lifting our pencils. Okay, so now it might go up higher, right? It might go like this. Who knows, right? Or it could go, let me see, I'll get a different color. Or it could just go as a straight line between those 2 points. We don't know. But it has to take on every single value, function value, in between 5 and -5, which means it has to pass through 0, right? So it has to pass, at some point it's got to pass through 1 and 2 and 3 and 4 and -1 and -2 and -3 and -4. Okay? All right, so let's take a look at this next example here. Suppose you park your car at a trailhead in a national park and begin a 2-hour hike to a lake at 7 a.m. on Friday morning. And then on Sunday morning, you leave the lake at 7 a.m. and start the 2-hour hike back to your car. Assume that the lake is 3 miles from your car. Let f of t be the distance from the car at t hours after 7 a.m. on Friday morning. And we're going to let g of t be your distance from the car at t hours after 7 a.m. on Sunday morning. Okay, so f of t is our Friday morning function, and g of t is our Sunday morning function. So the first thing we're asked is, are f and g continuous functions, right? Now, we have a context. The context here is that these functions represent your distance from the car, either on Friday or on Sunday, and we're assuming that we can't teleport, right? So we can't suddenly change distance in 0 time, right? We can't suddenly go from 1 mile from your car to 2 miles from your car in an instant, right? So we're going to say that yes, these functions are continuous, right? We can't suddenly change from one position to another in an instant. Okay. All right. Now evaluate f of 0, f of 2, g of 0, and g of 2. All right. So remember that f is our Friday morning function, right? We leave our car at t equals 0, which is 7 a.m., right? So t equals 0 is 7 a.m. And so when we leave our, at t equals 0, we're at the car. So we are 0 miles from the car. Okay, so we'll assume that these are, f and g are in miles. Miles, it's the distance from your car, t hours after 7 a.m. Okay, so we're going to measure our distance in miles. Now, after 2 hours, we're told it's a 2-hour hike. So at the end of 2 hours, we're at the lake and we're 3 miles from the car. Okay, so f of 2 is 3. Okay, because that's where we ended it. 3 miles from our car. Okay, so that's Friday morning. Now g, that's our Sunday morning function. And at the beginning of the day at 7 a.m., right, which is t equals 0 on Sunday, then we start out at the lake, which is 3 miles from our car, and then we hike back to the car, which is 0 miles from our car, right? Right? The car is 0 miles from the car. That makes sense. All right. So now we're going to define a new function, h of t. H of t is the difference between f of t of g and g of t. And this is just asking, is h of t continuous? All right. So we've built a function, right, from two other functions that are continuous. So that means h of t has to be continuous. All right. So it's just a difference of two continuous functions. So it's got to be continuous. All right. So let's look at what is h of 0. All right. H of 0 is just f of 0 minus g of 0, right? And so we can just take the difference between 0 minus 3, so it's a negative 3. And h of 2 is, again, it's just going to be f of 2 minus g of 2. All right, so we got 3 minus 0, which is a positive 3. All right, so where are we going with all this? So part E, that's where we're going with all this, is it's asking us to show that there is some point along the trail that you pass at exactly the same time on both days. All right, so how do we know when we're at the same point on the trail? All right, when does that happen? That happens when f of t is equal to g of t, right? The distance from the car is the same. If the distance from the car is the same, then we're at the same point on the trail. Okay, so we want to be at the same point at the same time. So that means that f of t minus g of t has to be equal to 0, right? Which is what we've defined to be h of t, right? So this means that h of t has to be 0. All right. Well, okay. So let's graph h of t, right? Let's graph what h of t must look like, right? So all we know about h of t is that at h of 0 is a negative 3, right? H of 0 is a negative 3. So 1, 2, 3, negative 3. So we're down here, and h at 2, 1, 2. H at 2 is a positive 3. Okay, so we've got to get from here to there, right? We got to get from here to there in some way or another. And if it's a continuous function, now I don't know, it could wiggle around, do all kinds of things, but it has to at some point pass through 0. All right. So we can say that there's got to be some time. We don't necessarily know what that time is, but at some time, h of t, where f of t minus g of t, has to be equal to 0 because we had to get from a negative 3 to a positive 3. And so that means that, when h of t is 0, that means that f of t equals g of t. All right, so the distance from your car must be the same at that, whatever that time is. The distance from your car must be the same at some time. All right. So now this is actually called, it has a name, it's called the intermediate value theorem. So it just says that suppose f is continuous on an interval and L is a number strictly between f of a and f of b, okay, where f of a and b aren't equal to each other, then there exists at least one number c in the interval between a and b satisfying f of c equals L. That's called the intermediate value theorem. All right, but all right, we got one more example and I'll meet you there.